Welcome back, everyone. In this video, we'll take a look at a collection of graphical limits at infinity. So the first one we will take a look at here is part A, the limit as x goes to negative infinity of our f of x function pictured on the right. Another way we can think about this is really what is the left-hand end behavior of our function. As x gets closer to negative infinity, what is our function behavior? So taking a look at that in our picture, we see that our function starts to level off as x decreases without bound. There appears to be somewhat of a horizontal asymptote here at the height of 1. This is a good indication that our limit value as x goes to negative infinity is at that asymptote. So we would say the limit as x goes to negative infinity here appears to be 1. In part B, we can take a look at the limit as x goes to positive infinity of the same function f of x. If we take a look at the right-hand end behavior, which this is referring to, we can say that as x increases without bound, my function is also increasing without bound on the right there. So we can say that this limit as x goes to infinity of f of x is equal to positive infinity. The next one, part C, takes a look at a one-sided limit. So the one-sided limit as x goes to negative 2 from above or from the positive end or the right. Let's follow our function and see where we are approaching as x approaches negative 2 from the right. Coming to the right, looks like our function is decreasing without bound, going down to negative infinity. If we approach that same value from the left side, this would be the left-hand endpoint in our limit in part D, the limit as x approaches negative 2 from the left. We would see that the function is going in the opposite direction. This is going to positive infinity. Notice that at negative 2, we are not defined. There is a vertical asymptote there at the line x equals negative 2. So even if we don't have a functional value again, the limit can still exist, or at least the one-sided limits in this case exist. In part E, we'll take a look at a two-sided limit. This is the limit as x goes to negative 1. So if we consider the two-sided limit as x goes to negative 1, we are approaching this hole in our graph at the height of 1. We don't mind that it's a hole in the graph as long as the two sides are approaching the same value, and so we would call that limit value positive 1. The last limit we'll take a look at is the limit as x goes to 3. We take a look at the limit as x goes to 3, we'll see that this is actually approaching a functional value filled in at the height of 4. So we can say that that limit as x approaches 3 from both sides is going to be equal to 4. Now, everything on the left side that we just calculated are limits that are asking the question, what is x approaching? Either from the left or the right or both sides. G through I will take a look at the functional values. This is fundamentally a different question than what we've just talked about with the limits. So let's take a look where we are defined, or if we are defined at these given points. So f of negative 1, we can say, is defined at the value of 3, even though its limit value is at 1. The functional value of 1, we'll take a look here, happens to have a hole as we cross x equals 1. This indicates that our function is undefined at this point, even though the limit existed at x equals 1 at -3. And then last but not least, we'll have part I, the functional value at 2. We can see this is approximately -1 on our graph. This is a functional value. It's continuous in this region. And we would say that this functional value comes out to -1. So through this exercise, I hope that you realize the difference between the idea of a limit and the functional value and what concepts separate them.